Hello YouTube, how you doing? Alright, so today we're going to talk about, again, another little esoteric topic that, as you clicked on the link, you have some interest in. We're going to talk about basically the implications of certain statistical methods used in psychological research, right? And some alternatives that we can use to the more mainstream statistical measures. So real quick, for some of you who may or may not know, when psychologists do research, they usually take a sample of people and they conduct an experiment, and then they collect data from each person, or a data point from each person, and then they somewhat average it into a mean, or they spread it out in a median. So normally we call these central tendency measures. When, as you can see, as the name implies, it's you're looking for the average or the weighted, like basically you want a picture of how this is generally all at once, right? So you get it, central tendency, the tendency for a central measure. The idea is just that, you know, you're just looking for the group, a number for the whole group to represent the whole group. Now what's interesting is when you get into really big samples and just people in general, populations in general, what you find is that the average is never really found anywhere in the environment. A quick example is something like gender. The average person is half male, half female, but we don't have that overtly, half male, half females in the world. I know there's arguments about that, but just take me for that for now. There's no one walking around with half a female body and half a male body. See what I'm saying? So, because of that, we can see that these central tendency measures aren't really found anywhere in reality. They're a way of describing reality, but they're not really found in reality. And one of their problems is that they don't really show us how things or processes or people change over time, right? They kind of, by summarizing everything together, we just get just one number, but we don't get we don't get to see this number through time, how it changes dynamically. So obviously, central tendency measures like mean and median are huge in psychology and in most other research and facilities and endeavors and methods, but there is a new wave of alternatives to this. Now, like I said, it may be accurate for a single point in time, but it doesn't show us how it works through time, how it changes through time. So the alternative to this is let me just grab this over here. Is we have two. One is called recurrence analysis, which you look for two things: how either a system changes over time, or how how a system changes over time, and how often. So you look at whether or not it changes and how often it changes. And what you get is, instead of getting like a single point, you get a series of points that make a certain shape. So what's interesting is, if you know about method and theory in psychology, that we have different kinds of data points. We have continuous or categorical, discrete, right? But using this method, it doesn't matter what you use. It fits all of them. And another thing I forgot to mention about central tendency measures, which isn't so good about them, is that usually most statistical analysis, they assume a certain kind of shape for the populations, and it's usually a normal curve. And we should know that populations don't always follow this normal curve. A good example would be certain polarizing issues where you don't have like a middle ground where most people are at. You have two humps, and then maybe like a little bit in the middle for people on the fence about a certain issue. But what you get with this kind of analysis is called recurrent analysis, like you're looking at changes and how often changes recur and how much of a change it is. You see, this is for discrete variables, right, like categoricals, and continuous variables, like scales or intervals. And as you can see, you don't get one data point, you get a series of points, and you get a certain kind of pattern. And this pattern, this shape, tells us about the behavior or any kind of system through time. So you see, instead of that discrete, like a median or a a median or a mean, we get an actual shape through time, and it shows us, it's almost like a real life or a real accurate line of regression. But again, things like line of regression, that kind of central tendency measure doesn't exist anywhere in the world. If you remember what line of regression is, it means whenever you see like a bunch of scatter plots for correlations and they try to predict it through time, you see that really straight line, that line doesn't exist. That no data point fits that line. That's just an average weight of the line. So this is what I'm talking about. So another example is something called fractal analysis. As you can see, if any of you are familiar with fractals, you know this on the this side over here, would that be your left, maybe? As you see, this is a fractal, and on the right here we have an actual. On the right here we have an actual pattern. So you see, it's self-similar all the way down. As you take a piece of it, you find more pieces of it that are similar along the way, just like these stars over here. It goes from, you know, as much as you magnify it, you still find the same kind of pattern and shape. So, I mean, I'm sure most of you know what fractals are. So, I just want to end with this, like a little paragraph here in this book that I'm reading from. It's called Embodied Cognition, the Handbook. It's edited by Lawrence Shapiro from Wisconsin, University of Madison, Wisconsin. And the chapter in this is it right here, by these guys at the University of Cincinnati. I don't know if you can see the names, but it's Michael J. Richardson and Anthony Chimero, and they work with embodied cognition and dynamical systems, so it's obviously they'd write a chapter like this. But there's a good paragraph that I just want to read real quick, which kind of sums up my point in a nutshell. Researchers in cognitive and behavioral psychology commonly collapse repeated measurements into summary variables, such as the mean and the standard deviation, under the assumption that the measured data contain uncorrelated variance that is normally distributed. Real-time behavior and cognition, however, are rarely static, and thus summary statistics often reveal little about how a system evolves over time. Indeed, time series recordings of human performance and cognition typically contain various levels of correlated variance or non-random fluctuations that are not normally distributed, and moreover are structured in a fractal or self-similar manner. So that's what I'm trying to say here, is that it's good to have both. You know, I'm not saying we just throw out central tendency measures, but at the same time, I think researchers and people in general should start thinking about how things evolve through time, dynamically. And when you see, like, when you try to understand something and you want to know its average, try to see its average at a later time. You see what I'm saying? So it just, this is going beyond just like behavioral and cognitive research. You can just use this in everyday life, where, you know, you have an example for something and try to not take that category and just base it on that one example. Try to see that example through time and not just summarize it, but try to see that time and try to follow that curve or that shape. Because if you find it, you realize it's self-similar, and then you can predict, you know. In a later video, I'll go over something called pink noise, or the 1F scaling ratio. It's related to white noise, but it's actually found in nature and in human behavior, and even in financial markets like stock markets and stuff. So I think that would be really interesting for a later video. So it's already under 10 minutes. I'll leave it at that. Thanks for watching, and please comment and let me know what you think. Bye.